All right, so I'm going through the practice for 2.5, solving quadratics by factoring. Looking at the first one, we can already see that our equation is equal to 0, so we don't need to manipulate anything. We can also see that there are that we can't factor out a greatest common factor because the greatest common factor between these three terms is 1. That means we can go ahead and jump right in with our magic x. So we want two things that are going to multiply to 21, add to -10. The only thing I can think of there is x minus 7 and x minus 3. We can do x squared plus -7x plus -3x. And then I'm going to do plus 21. That's equal to 0. Put parentheses around the first two terms and the second two terms. The greatest common factor of x squared plus -7x is going to be x. That's going to leave me with x and plus a negative. That's going to be the same as subtraction. So we can just write that -7 by x minus 7. And then if we have the greatest common factor between -3x plus 21, remember we always want to factor out that negative sign. If this x term has a negative, we always want to make sure to factor it out. And then in order to make sure that when we do -3 times what's in the parentheses, we get back to positive 21, we want to adjust the sign so that that is x minus 7. Right, that way -3 times -7 gets us back our 21. And then now we can combine what's outside the parentheses with what's still inside, and we could do x minus 3 times x minus 7 is equal to 0. And remember, this is going to be equal to 0 when this is 0 or when this is 0. So we're going to try those independently, right? If x minus 3 is equal to 0, then the solution will be solved, or the equation will be solved, or when x minus 7 is equal to 0. The equation will be solved. And this is going to happen when x is equal to 3, right? X minus 3 will be 0 when x is 3. X minus 7 will be 0 when x is 7. And so your answer is the set that contains 3 and 7. Okay. Looking at this one, we have it equal to 0 already, so we don't need to worry about that. We also can't factor out a GCF because the greatest common factor between these three terms is just 1. So go ahead and do our magic x. We want two things that are going to multiply to -90, right? A times c, and add to -13. And think about what is going to multiply to 90, add to -13. Well, we could do 15 and 6, but that's not going to help us. We could do 9 and 10. It's not the most helpful. Um, could do 30 and 3, not the most helpful. Yeah, let's go through it. Let's make the factor tree for 90. 90 divided by 1 is 90. 90 divided by 2 is 45. 90 divided by 3 is 30. 90 divided by 4 is going to be 22.5. 90 divided by 5 is 18. 90 divided by 6 is 15. And here, because this is negative, we know one of these is going to be positive, one of these is going to be negative, and so we're looking for which row has a difference of 13. That's going to be this one. So we can see that we are going to want to use -5, or nope, we're going to want to use +5 and -18. We can break up our b term into 3x squared plus 5x plus a -18x minus 30 is equal to 0. Put parentheses there and there. If we factor out the greatest common factor from this first term, we can just do, or from this first parentheses, we can only do x times 3x squared plus 5. From the second term, the greatest common factor between -18x and -30, that's going to be -3. Oh no, it's going to be -6. And what's left over? Well, 3 times 6, so it's going to be 18. So we want 3x, and then 6 plus 5 is going to give us negative 6 times 5 is going to give us negative 30. This means that for our final step, we can do x minus 6 times 3x squared plus 5 is equal to 0. And just as before, we want to set each of these equal to 0. So x minus 6 is equal to 0. 3x, and there should not be a squared there. 3x plus 5 is equal to 0. The first one will be equal to 0 and x is equal to 6. And for this one, we need to solve it out. We can do minus 5 minus 5. 3x is equal to negative 5. X is equal to negative 5 over 3. And so your final answer is the set that contains negative 5 over 3 and 6. All right, this one we have to do a little bit more work because we have an x squared here. So before we can factor anything, we want to make sure that's equal to 0, which means we want to move this x squared over to this side. We're going to get 6x squared plus 8x is equal to 0, right? X squared minus x squared on the right side, that gives us 0. Looking at this, we can factor out a greatest common factor. And actually, we don't even need to use the magic x here, because if we factor out our greatest common factor of 2x, then we're left with 3x plus 4. Well, this is going to be equal to 0 when either of these two factors is equal to 0. Right? If 2x is 0, then 0 times this is going to be 0. When 3x plus 4 is 0, then 0 times whatever 2x is also going to be 0. So 2x is equal to 0 when x is equal to 0. And 2 times 0 is the only way to get to 0. 3x plus 4 equal to 0. Well, for that we need to solve it. We need to subtract 4 from both sides. We get 3x is equal to negative 4. X is equal to negative 4/3. And our solution is x is equal to the set that contains negative 4/3 and 0. All right, for this one as well, we don't have it equal to 0, so we want to start by subtracting x from both sides. That's going to give us 4x squared minus 12x is equal to negative 9. Then we want to add 9 to both sides. That's going to give you 4x squared minus 12x plus 9 is equal to 0. So now we want to go ahead and factor. And I don't see a GCF that we can pull out. Right? Maybe a GCF is equal to 1, but don't see anything more than that. So let's think of two numbers that are going to multiply to 36 and are going to add, and remember that 36 came from 4 and 9 being multiplied, and are going to add to negative 12. Well, I see negative 6 and negative 6. So let's rewrite this: 4x squared plus negative 6x plus negative 6x plus 9. And now let's try and factor. We go to factor out the GCF of this first set of parentheses. We're going to do 2x. And then inside parentheses, we will have 2x minus 3. And when we go to factor out over here, remember you always want to factor that negative side out. The negative sign out, so we're going to have negative 3 times 2x minus 3. And now we can combine what we have on the outside. 2x minus 3 times 2x minus 3 is equal to 0. And notice here, these two factors are the exact same. And that means our one and only answer is going to happen when 2x minus 3 is equal to 0. We add 3 to either side. 2x is equal to 3. X is equal to 3 over 2. Okay. Now let's look at the SAT questions. Here we have an equation. D minus 30 times D plus 30 minus 7 is equal to negative 7. If we think about how can we how can we get something in factored form equal to 0? Well, what if we just add 7 to both sides, right? Then we get D minus 30 times D plus 30 is equal to 0. And that's going to be true when d minus 30 is equal to 0 or d plus 30 is equal to 0, right? Using our zero multiplication property. D minus 30 will be equal to 0 when d is 30, and d plus 30 will be equal to 0 when d is negative 30. So either one of these two answers are going to work, right? So the entire solution is x is equal to plus or minus 30. But keep in mind, for the SAT, it's saying give a solutions. You would only give one of the two. Okay. What is the product of the solutions to the given equation? Yeah, so here we can read the solutions pretty straightforwardly. Remember, this will multiply to 0 when any one of the three factors itself is 0. So x minus 4 is equal to 0 when x is equal to 4. X plus 2 is equal to 0 when x is equal to negative 2. And x minus 1 is equal to 0 when x is equal to 1. Right? As long as one of the three products is equal to 0, the entire thing will be equal to 0. So keep in mind, what is this asking for? This is asking for the product of the solutions. So we have our three solutions here. All we have to do to find the product is multiply them all together. So 4 times negative 2 times negative 1, that would be d negative